Good morning. My name is Annalisa Tassoni and I am the scientific coordinator of the Prolific Project. The Prolific Project is a research and innovation action of the duration of 4 years. The budget is of about 5.3 million euros and was financed by BBI under H2020 program. The partners of Prolific are 17, of which 3 large companies, 10 small-medium enterprises, 4 research institutions belonging to 8 different countries. Prolific will valorize agro-industrial and food processing residues. We know that about 2 billion tons of agro-food waste are produced every year. This waste is, however, still a source of valuable compounds such as proteins, fibers, and polyphenols. The optimization of innovative and sustainable biorefinery extraction processes starting from these residues will bring to the extraction of nutritional and bioactive compounds. In particular, will contribute to address the projected high future demand of proteins for food and animal feed. Prolific feedstock consists of processing residues from legumes, peas, green beans, and chickpeas, from fungi, cuttings and leftover of 3 different fungi species, and from coffee, silver skin and coffee green beans. The amount and the presence of these processing residues is very relevant in Europe, as it can be seen from the maps that represent, for example, the European production of fungi and green peas. Prolific optimizes integrated, flexible, and scalable cascade of processes for the extraction of proteins and other bioactive molecules from legumes, fungi, and coffee agro-industrial side streams. Residues are firstly used for the extraction of protein and then, following a cascading approach, for the isolation of other compounds such as fibers, ketones, and polyphenols. The extracts at the end are used for the production of prototypes in 4 different industrial sectors such as food, feed, cosmetic, and packaging. So far, the main results of Prolific are optimized methodologies for the extraction of valuable compounds from legumes, fungi, and coffee processing residues. By means of these processes, valuable compounds have been extracted, such as proteins, peptides, fibers, polyphenols, and many more. 5 new and completely bio-based value chains have been set up. Also, at the end of the project, 16 prototypes will be produced in the food, feed, cosmetic, and packaging industrial sectors. Here you can see some of our first results. Proteins from legumes, hyperprotein bread, protein extrudates for the production of vegan meat surrogate products, coffee capsules, including coffee silver skin. Thank you for your attention and feel free to contact us.
Hello, my name is Anna Maria Celli and I am a professor of the Department of Civil, Chemical, Environmental and Materials Engineering of the University of Bologna. On behalf of the Prolific Consortium, we welcome you here in Italy, in our department, in our labs of polymer science. We are very excited to have you here and to have some fun together making a chemistry experiment on the preparation of an antibacterial film. So don't wait any longer and let's go to the lab. This is one of our chemical labs where Michaela is working. Hello, Michaela.
Hello, everyone.
Let me introduce Michaela. Michaela is one of our assistant professors, and she will do the experiment with us today. This is a typical chemical lab where we carry out synthesis of polymers that will become plastics for different applications. Now Michaela is preparing a lab position where the reactor of synthesis is ready for a new experiment. But Michaela, we have to go to do our experiment to prepare a new antibacterial. And Michaela, what do you need for our experiment?
For our experiment we need a water solution containing a polymer and a molecule characterized by antibacterial properties that can be extracted from agro-industrial residue. This solution is composed by this powder containing polymer and the active molecule.
Indeed, in a prolific agro-industrial residues become a resource of very precious molecules with a specific activity that can be exploited to produce new materials. Michaela has a PET film, polyethylene terephthalate, that is a commercial polymer widely used for its properties, transparency, good mechanical properties, and also gas barrier properties. This material is used for packaging application, but it is not antibacterial. Now, in our experiment, we will transform this PET film in an antibacterial film. Now Michaela is depositing a very small amount of our antibacterial solution on the film. And she will be able to spread this solution on the surface of the material using this coater equipment. A new polymeric layer has been spread on the surface of the film and now must be dried. Okay, the film is ready. We can observe that he maintained the transparency of the PET film, and now he is antibacterial. So the experiment is done.
Yes, I hope you enjoyed it.
Thank you, Michaela.
You're welcome.
So this was a very simple demonstration of activities that we are carrying out in Prolific. The project aims at extracting active molecules from agro-industrial residues and exploit them to obtain new products, for example, active packaging. If you want to know more about our project, please follow us on the website or on Twitter and spread it. Thank you and bye-bye.